40s and 50s, many experts were saying no computer will ever beat a human chess grandmaster because the level of understanding of chess required to play at that level is beyond the capacity of a machine. But it turned out actually to be possible, and in 97 or 98, I don't actually remember the year, it happened in a 3-game match between IBM's Deep Blue computer and Gary Kasparov. But human language is actually much harder for a machine than chess. Chess is very mathematically well defined. What you can do in each step, there's only a certain number of moves you can make. And a computer plays chess by searching what all those possible moves are. For natural language processing, there's too much ambiguity. There's too many possible meanings. There's too many ways to say the same thing. And one of the most important lessons that artificial intelligence as a science has learned over the past 50 years is that the most basic human skills we acquire within the first few years of our lives, are by far the most difficult for computers to acquire. Yet things that we as people find difficult, like math, like playing chess, things that we actually associate with the word intelligence in humans are not that hard for computers. So the challenge here really is something that's extremely difficult for computers and extremely easy for people, and that is natural language processing. And just think about the way computers work now. You've got web search where you can type in, whatever you want. You can type in a question, you get back a bunch of documents. You're expected to read those documents and find the answer. Another way you get answers out of systems in a more traditional way is databases. But databases are very, very precise. You have to type in exactly the right name. If it's slightly misspelled, if it's not spelled the way it is there. If it was represented in the database as A. Einstein and you asked for Albert Einstein, you wouldn't get that. It's got to match exactly. But that's not how human language works. And even more importantly for us, most of human knowledge is not stored in databases, although there's a lot. By far, something like 80 to 90% of human knowledge available in digital form is available in text. It's available written in some natural language. So there is an English passage that answers the question, where was Einstein born? And our challenge was, build a computer system that's capable of understanding that a passage like that has an answer to a question like that. Very hard. Here's another example of how language can be used in ways that is extremely difficult to write a computer program that will get the right answer here. If leadership is an art, then surely Jack Welch has proved himself a master painter during his tenure at GE. So if you want, Jack Welch is a famous CEO of General Electric. So again, there are 5 dimensions that we like to talk about that make Jeopardy challenging and interesting to study from a scientific perspective. It's a very broad domain. People find this part of it challenging. You have to know a lot about a lot of different things. The language is pretty challenging. The questions are written by writers. The writers aren't actually themselves interested in the answer to the question. They already know. They're writing to entertain as well as to inform, as well as to sort of ask a question. People do not find this very difficult at all. You have to be precise. You have to know you have to have the right answers most of the time. And in Jeopardy, you have to know what you know. You need to compute a confidence. You need to buzz in. You choose whether to answer. And if you choose to answer and win, you win money. If you choose to answer and lose, you lose money. So you can't just try to answer every question. You're going to lose money. So that requires confidence. And you got to do it fast. You have about 2 seconds to answer. We achieved what we call champion level performance. I think regardless of the outcome today, anyone who's seen the matches thus far has seen that Watson plays pretty well and deserves to be there between the 2 greatest human players ever to play this game. We basically do this using something that we're calling deep analytics. We split the question up into a variety of different pieces and try to analyze those different pieces. It's actually rarely the case that Watson really understands the question in the same way that people understand it. And to be sure, just as Deep Blue did not play chess in any way remotely resembling the way a chess grandmaster plays chess, but still was able to play at the grandmaster level, Watson does not answer questions the way people do. It does not understand the questions the way people do, and it does not find the answers the way people do. Yet it's still performing at Jeopardy champion level. We do this fast because we use a something load of processors. Okay, big hunking computer there. We've got 28,000 processing cores, very tightly connected, nothing on disk, everything's in memory. All the sources that Watson uses, encyclopedias, dictionaries, thesauri, they're all stored in memory, and those are searched for the answers. We played 55 games against Jeopardy players who won at least 5 games during the season and who qualified for the Jeopardy Tournament of Champions. So these were, again, championship level players. And we won 71% of those games, qualifying us essentially to play at the Tournament of Champions. So I'm going to take a couple minutes here now to talk about the future of Watson. One of the ways that Watson really tries to understand questions and get answers is something we call evidence-based evaluation. So it breaks questions up into pieces and tries to find answers and evidence for those answers based on the different pieces. Usually it doesn't understand the question in its entirety, but gets answers by synthesizing the result of these different dimensions of evidence. So if we take a question like this one, Chile shares its longest land border with this country, the correct answer is Argentina. If you use web search is based primarily on this, what we call the popularity dimension. It sort of counts the number of times words are mentioned in order to rank possibilities. The more it's mentioned, the higher it will be ranked. So if you go based only on popularity, you're going to get Bolivia as an answer because the search terms border and Chile occur more frequently in conjunction with Bolivia because there was a border dispute between Bolivia and Chile that was reported in the news. And it was reported over and over again during a several-year period where this border dispute was underway. But it's not the right answer. So Watson uses other forms of evidence. Although it does use that same dimension, it has many other dimensions of evidence that it collects for answers. One of them is the classification dimension. Here we know it's looking for a country. Last night we saw, for example, the U.S. city as the classification dimension. Watson did not actually get that right because it discounted the importance of the classification dimension because the U.S. city was in the Jeopardy category, which is not always a reliable source of type information. We also rank all our sources, so in a sense, Watson is capable of dealing with lies. It understands how reliable its various sources are with respect to answers that it's been trained on from previous Jeopardy games. Passive support is about, are there passages in my sources that sort of state the question with this answer or that answer? So is there something like a statement in my sources that say, Chile shares its longest land border with Argentina? That would be passive support for Argentina as an answer. And then location information, which we did not have last night for the Toronto example, again, because the location information was in the category, Watson failed to process it properly. In this case, the location information is processed properly. It's looking for countries that border Chile, and both Argentina and Bolivia have positive evidence there. So for the future, where is this idea? This is how Watson understands a question and tries to judge whether the answers it's considering are correct. It's not the way people do it. But there are other uses for this type of evidence-based technology. We see a lot of application, and we're really excited about the possibilities in life sciences, obviously help desk support, law, and so forth, financial markets. So here's a kind of evidence profile now for some kind of medical use case. You might have how different symptoms give evidence for a particular diagnosis, how the family history it correlates with or indicates some particular diagnosis. and so forth. And the way Watson works is it combines these different evidence dimensions to produce a confidence in each one of its answers. So imagine you had yourself a medical situation in which you had data about a patient's symptoms, the family history, the patient's specific history, what medications they're taking, etc. You could make hypotheses about the different diagnoses that are explained by this set of symptoms and history, and etc. And Watson would gather together all the evidence from a variety of sources. It may change as new inputs come in. I mean, maybe the link to the patient's doctor's office is a little bit slower, and the ranking of the things would change in time as new evidence is gathered. And ultimately, those different evidence dimensions are combined to produce a confidence in some kind of diagnosis. So let me just end with this slide on the board. This is just a little bit of diagram for people who are interested about how Watson actually works during the game. So we have Watson's actual powerful QA engine that's sitting there in the back. We call it the back end. Sometimes it goes down. And that part of the system is the one with all the processing power and all the memory. But there's a front end that actually manages the interaction with the game system, understands the game state, like how much money each player has, and it also has the strategy implemented. So the strategy from a computational perspective is something that's extremely difficult for people to manage during the game, but it's relatively simple if it's been done right, and it has. It's relatively simple for a computer, so that actually runs on the front end. It doesn't require, 2,800 cores to figure out what to bet or to decide what clue to select next. Okay, let me stop there.
Will computers ever be self-aware in the way we think about self-awareness? So Selmer, take a stab at that. Do you think we'll ever have self-aware computers?
No, I don't think a computer will ever be self-aware, but we can engineer a computer to seem to be self-aware, just like we can engineer a machine able to handle English in a way that convinces some people it knows what it's doing. There is the great test for self-consciousness and self-awareness, which puts a red dot on the forehead, or if it was a robot, on the chassis, if you will, of the robot, and then ask it to look in a mirror, and if it realizes that that dot is on itself, as evidenced by its behavior in trying to remove it, we classify the dolphin, the chimp, and the human. Those are the only biological creatures able to pass that. We classify the creature as self-aware. So, concretizing what I started by saying, we can engineer a robot, which when looking in a mirror, will try to remove the red dot that it perceives, and along with a graduate student, Naveen Sundarji, in my lab, we actually are working on that.
Wow, that sounds really
When we were sitting there and seeing that final Jeopardy question last night, we were pretty surprised with the answer. Although we're accustomed to Watson making mistakes that seem pretty silly to people. Still, Toronto, Toronto, great city, great city. I'm talking, of course, we're talking about Toronto, Indiana, great place.
Two airports.
Yeah, love it. So that was a big surprise. Still, we were expecting surprises like that.
Yeah, I guess I have a high level and low level surprise. At a high level, I was surprised at just how great a job Watson was doing with really understanding just a small piece of the question and of the sentences that it was using for evidence. The fact that it could get into the winner's cloud with a fairly small amount of understanding of what was being asked, I thought that was pretty surprising. And then the lower level, the wagering, the bets were a little surprising to me, that it had the fairly large bet and then the really small bet and then the tiny bet.
I found the bets really surprising. Anna?
I'll take a different approach than Chris and point out some questions we actually got right. There was a category called Name the Decade that has a bunch of facts that you have to get what decade it was in. And I think we actually have maybe low confidence we can buzz in on them, but we actually had a fair number of them right. And a lot of people think, oh, that's easy, you just look up the fact, the date and the decade. We didn't program Watson to do that, right? So we didn't know we were going to get these categories. We actually kind of figured that on its own, that decades were important, and had learned and acquired all of this knowledge, these events that occurred in the decades, and it was able to solve this problem. And in a way, even though I know how it kind of did this into the covers, I was still sort of impressed that it kind of, in a way, had figured out on its own how to solve this problem of figure out what decade these events are in without being told. And this applies to a whole bunch of other things besides naming decades. So it's kind of generalizing and learning to solve new problems in a sense that way. That was kind of surprising.
Son?
So I was not surprised at the betting at all, but I was surprised at the level of dominance. Really, I did not expect Watson to do as well as it did. It was very impressive. But this may be partly because I felt like the last question was actually interesting because it was a fairly complicated sentence structure, and I somehow had this impression of more Jeopardy questions being like that, and so I still expected Watson to do very well, but I didn't expect it to get like so many questions right, especially like in those really long streaks that it got. So that was impressive to me.
Very quickly, I was lucky enough to be at IBM a few times before this, saw the architecture, saw some preliminary games, and I know the minds involved, and honestly, I am still shocked that the humans were not completely shut out.
Well.
I hope you're not going to go back and change any of my grades.
We don't have a straight A average now. It's almost time for the broadcast, so let me remind you of the etiquette. That's very interesting. And remind you a little bit more, all these giant commercials that we're actually trying not to look at are really quite bizarre. Okay, here's the etiquette. Since Jeopardy airs at different times around the country, you can follow along in your programs. Some of you might have already found out the results of tonight's competition. Do not tell us. We all want to find out at the end of this show.